approaching a point where we're going to transition to learning about transformations of functions. They're getting pretty good at identifying key features of functions on graphs on paper. What we're trying to do now is combine their calculator skills and have them more comfortable comparing key features of functions that are on a calculator screen instead of on paper. So we're nearing the end of this identifying key features part of our unit, and we're going to be moving towards learning about transformations of functions and how those affect the key features. All right, so today I'd like you to first take a look at your problems from yesterday. Hopefully yesterday it was a little easier doing these 4 problems, but I think that probably in each one of these there was something that maybe you had to stop and say, I don't know if I've ever seen that before. So I've picked out a few questions that I want to ask you about those problems. They're going to come to your screen as a quick poll. And I want you to think about it yourself and not share with anybody else what you thought about this problem. It's multiple choice, so please don't just guess, but actually think about, if this isn't the same as what you put, which one of these answers makes the most sense? I'll out the bottom one for you.
Because you don't have an arrow that is going towards the left.
You don't have an arrow at all on the left, and so you knew that it couldn't fall to the left? I think there's a lot of ways that teachers can use polling to make students' thinking visible. I think in this particular case, it was nice to, when going in, knowing that the students were not going to have correct answers. I thought it was a great way for them to be able to see how other students were thinking about the questions, but not so intimidating where they had to provide their answer. They actually got to choose from several answers that I knew, having thought about it ahead of time, could be possible answers. What I want you to do in your group is I want you to ask in your group what they answered, and I want you to try to convince somebody in your group that you're right.
Sophia, what'd you answer?
So it rise to the right and then so the next one, -2.
And after that, I feel like the students were able to explain and argue with each other to where they could actually feel more comfortable with the answer that they had chosen.
Well, I can get what you see. Stop. So that has a point. You can see where the point's at.
So I think that when we allow students that time to process and discuss, we gain a lot from seeing that happen. We gain the ability to see where our students really are, and they gain the chance to actually sit back and process what you're trying to show them. All right, let's do something, please. Don't share. We're going to revote. So one of the mathematical practice standards I was really going for was the critiquing the reasoning of others. And I feel like they were very motivated to do that because they wanted to know if they were right. So I feel like as soon as I gave them that chance to talk to each other about what they thought their answer was and listen to other students explain their point of view, I feel like it gave them a chance to engage in that practice standard. The graph looks like this, right? Yeah. Okay. So Cale's argument is going to the left. This point isn't behaving. I kind of like the way you said that. It's not behaving. What's wrong with that point? It's not behaving. I also wanted them to start seeing the structure to equations. So I feel like with the quadratic example, something that they might be familiar with from Algebra 1, they might start seeing some structure to the way the equation looks and the way the graph is similar to the parent function of the quadratic. I just need an argument for the 12 of you who think it's now that we should say it's the point -4, 2, and all 4 of you said that the first time. Why do you feel so strongly about that?
Well, it definitely rises to the right, and I think it falls to the left because, it stops at -4, -2. That's why I thought that.
If there's no end behavior, then that means it's just coming out of nowhere.
I don't really think this is wrong. By the way you argued, I think that that's probably okay, but I really like this answer a little better. So if that happens to you again on a graph, let's go with this one. think one of the things I was also going for is to use the tools in front of you. If I'm asking you about an equation that you have no idea what the graph looks like, well, with this tool in front of you that can actually plot points and use a little bit of geometry tools to discover some things about the function, you might actually be able to answer a question you had no idea you could answer going in. The other thing I noticed was students were really focused on this idea of the asymptote, and I thought that they were really attending to precision there. I thought perhaps they had no idea what they were really saying, but they started to get more and more precise about what it meant to approach the number 2, and I thought that was beautiful. So what did we say about this domain and range thing that's really tempting to do? All real numbers, all real numbers, all real numbers. Very tempting. Okay. But probably not the answer all the time, right? Okay, so let's do the same thing. If you could, ask your people in your group what they answered and try to convince them that you're right. Did you guys all agree again? Just curious. No?
So it's greater than, like,
I don't think that's right.
when we're talking about the range, are we trying to talk about the values, everything that it touches or everything that it doesn't? Like,
I know what you're saying. Sometimes the best way to think about it is what it doesn't touch. But then your answer should be what it does touch, okay?
yeah, so I...
Yeah.
In the past years, we definitely did use some group work, but we didn't use it to the extent that we are this year. And I really like the fact that we're using it a lot more, because I do better when it's just me bouncing ideas off of one another instead of me trying to sit down with my book and say, okay, you know, this is right because da-da-da-da, or this is wrong because X, Y, and Z.
I need an argument to convince me or convince this person, whoever it is, that this is the right answer, because 13 of you are pretty sure that's it. Kelly?
Both of the arrows are pointing down, so that
Okay.
means that obviously the graph probably isn't going to come back up.
Okay.
Right? So then everything, any y value is going to be, or the function of x value is going to be less than or equal to 2, because that's the top.
Pretty convincing to me. So in the partner activity, I actually had 3 different levels of partner work that I was handing out. One level was for 2 students who I felt were just getting the material, maybe not quite confident in their learning. Another set of materials was for a student who really understands, in my opinion, and someone who's still struggling a little bit. And the third set were for 2 students who have been giving me lots of answers, and I know they're very confident in their work. So nobody really knew that that was going on. They just knew that their partner's information would be different than theirs. So in the end, when they come back and compare, nobody actually even knows there was differentiated instruction going on. All right, what did I just put in front of you? Guess what? They're not in order. But these are the answers for the entire sheet. And you can check and sort of like a puzzle. Which one did I get? Which one did I not get? But not right now. Put that away. That's your homework. All right, so from the pictures that we've talked about with the graph selfies, and from a little bit of knowledge of what the equations might be, which of those do you think should look the most like this equation? Which picture on your graph selfies might I identify with this equation, just based on what you know so far? Linear. The linear? Why, Drew? It's just a straight line. This looks like a straight line. Sure does. It looks kind of curved on the bottom. Oh, do lines curve? No. Not the ones I know of. Yeah, so lines don't curve. So maybe it's linear because of the picture we're looking at here. What about this equation? Does it match what you know from Algebra 1 about linear equations? No. Not so much? Okay, another idea. Callie?
I was thinking maybe quadratic.
Why do you think that?
Because it has the x, it kind of has the x to the second.
Tools on the graphing calculator really help, I think. And the way you can like drag stuff. It's more hands-on, which is like how I like to learn, and I know a lot of my peers like to learn that way. So it just makes everything easier and a lot easier to comprehend than just take down these notes, do things this way. It's not black and white, it's colorful.
Oh, okay.
Yeah.
That's pretty well. Like,
My stuff is basic. It's boring.
Mine has 3 x-intercepts.
What is X?
I'm gonna get you.
Yeah.
It's fancy stuff.
That one.
It's odd. Yours is
How do you tell if it's even wrong?
odd reflects over the x-axis, and even goes to the y.
So I have even.
Yes.
My x-intercepts.
Okay, what is it?
Increasing, decreasing.
Oh.
Well, when it increases, this is increasing right now because it's going up. Just think about that. And yours never really decreases, it just kind of flattens out. Mine, you see how it goes up and it goes back down? That's going to be a decrease. This is increasing.
So what would you say?
A lot of times we kind of rush through day to day, and the way this curriculum is designed, I really feel like my students are gaining more in less time.
They always seem to get the same answer, and I'm usually the odd person out, and they'll ask me well, how did you get that? Like, okay, tell me the steps that you took to get that answer. And then they just help me work through it, and so we kind of ask the same questions, but not ever in the same way twice.